35 watts. Okay, I saved, what, 35 watts? Times 2, okay, 70 watts. I'm sorry, those graphic cards, we're pushing 200 watts per card.
Right.
So I can't get enough by scaling down the CPUs. The CPUs are not what I'll call the ultimate power hog. Right now, graphics is. Graphics is our biggest challenge, and it's a power hog. And so now I have to have enough power in the supply as well as on the motherboard itself. And then it becomes a thermal and acoustics issue as well. When you put that much power in there, guess what? That power turns out to be heat. How do I get it out of the box and do it efficiently?
Have you thought about adding water cooling to the graphics also?
We continue to look at all kinds of alternatives in terms of how you manage the thermals inside, including water cooling in all dimensions. Graphics, obviously we've done it on the CPUs already. As we think the technology will avail itself and it's affordable, we'll certainly consider it.
Okay, thanks Terry. Well, let me move on to the next demo that I have for you. This one is in no way as visually interesting as the ones you saw there, but conceptually it's really exciting. So we're talking at the moment, but we're continuing our discussion about GPU compute. And I don't know if anyone covered GTC last week. Was anyone there? So GTC was the GPU technology conference. And so some of the demos that I've got here were actually shown there as well. In fact, this very workstation came back from GTC, which saved me the work of setting it up. I just switched it on and found the demo on there, good to go. So this is a Z400 workstation, which is our performance single socket workstation. It's actually our biggest seller right now because it suits so many people for so many applications. What we've done to this workstation just this month, last month now, is we've added support for the NVIDIA Tesla C2050 card. And remember what Terry said about power? Well, to make that happen, we've actually provided a new power supply for this product. It's an optional power supply at 600 watts. A standard Z400 has 475 watts envelope in the power supply. This one is 600. So that gives you access to the Tesla card. So I'm going to show you a demo that is not very prepossessing, but it does illustrate the point. So I've actually started it. This is MATLAB from MathWorks, and NVIDIA has been working very closely with them because it's the perfect kind of application for GPU compute. GPUs, historically, in the old days of totally dedicated, focused 3D hardware for OpenGL, or even older like FIGS or PEX or Starbase, going way, way back. Way back. 3D graphics is essentially two things: floating point numbers and matrices. That's what 3D graphics is all about. Matrix operations on floating point numbers. Well, so if you've got a math problem that is floating point and can be expressed as a matrix of numbers that you're doing some kind of convolution to or computation on, then that graphics hardware completely screams. It's ideal for that kind of problem. So it just ran one here. Let me show you what it did. It's a bit kind of odd. It's actually a demo from MathWorks which calculates the relative areas of all the states in the contiguous US. And what it does is it takes the map outline, and I guess this is Bay Area, it's the San Francisco Peninsula right here. So it takes the outline and fires dots at it randomly in floating point locations. And it counts how many dots fell inside the state and how many fell outside the state. And if you do that with enough dots, it gives you an idea of the area of the state. The result of that computation looks like this. No surprise, Texas is biggest. This scale here represents percent. So up here at the top, about 8%. Texas is approaching 8% of the contiguous US by area. Second is California, so 5% of the US is California, contiguous US. Colorado is a green state, but we knew that anyway. All right, so that's what it did. More interesting, I suppose, is the results, although it's not very easy to see from where you're sitting. The graph, the axis along this way is size of problem. In other words, how many columns there are in that matrix. And it goes out here to about 66,000. So big, lots and lots of numbers. The green line that runs horizontally here, which is normalized to 1, if anyone's done any benchmark, you've been normalizing to get your head around the data. That green line is a quad-core CPU. Probably a Xeon, but it doesn't say. Quad-core CPU. This blue line underneath it, at about half the performance, is a single core. So quad-core gives you a reasonably good boost, about 2x. The green line at the top here is this product, the C2050, and the red line is the smaller brother, the C1060, also from NVIDIA, another Tesla implementation. And you can see for these big problems here, the C2050 is a little over 10 times as fast as a quad-core CPU. So for this class of calculation, this class of computation, GPU compute is huge. The last few years, we're talking about workstation performance, the message has been more cores, more cores, more cores, learn how to use more cores, learn how to run multiple applications simultaneously. You've heard that message from HP and from Intel and everybody. But just recently, the credibility and the number of real-life applications that are using GPU compute is becoming big in the workstation space. All right, any questions at this point? I have one more GPU compute demo, and then we'll talk about benchmarks. Excuse me, scooting around my wheels.
Yeah, just if I could come.
Industry is another place where problems are getting bigger all the time. We've all made the transition. I don't know what your devices are. That one says HD on it. You're probably not shooting above 720 there, but in the industry, everyone's made the transition to HD, pretty much, right? And the number of pixels you have to push for HD is much higher than it was for SD. In the film industry, there's 2K, there's 4K, and Red cameras have made those large formats more accessible to more people, and people are shooting with Red camera. And so people are now got these high resolution video assets, and they want to layer them on top of each other. Let's see, is this going to go? Yes, there we go. All right. I love it when I show a demo that's not working too well. I was told that that one of the basics of marketing is you start with pain, right? You say to the customer, I understand the problems you're having. You're having problems like this where you just cannot do real-time playback of all these layers of video. Poor customer. But we have a solution. So what's going on here is it's doing the compositing in software. And so the CPU is very busy and the experience is not very good. You can improve the flow of playback, but by throwing away some of your on-screen resolution, it gets kind of blurry and not a nice place to be. So this is a Z400, and the graphics card I have in here is NVIDIA Quadro 5000. There's a new Fermi line. It's the smaller brother to the 6000s I have in the Z800. And with Adobe Premiere Pro CS5, I can change the project settings to enable what they call the Mercury Playback Engine GPU acceleration. By the way, I have to get these here in my head. Mercury is the GPU acceleration from Adobe. Quicksilver is a GPU acceleration from Autodesk. It's interesting how these two names are kind of lined right up alongside each other. Okay, so I'm now turning on the GPU accelerated playback. And life is good. So by doing the investments at Adobe, where they enabled GPU acceleration of playback, they have delivered so much capability to their users to do high resolution, multiple layer video with high playback rates and high, you can scrub and everything. It's a really good experience now. And of course, that total solution is qualified very well on our workstations. We make sure Adobe gets our workstations, they test, they qualify. Yep, this one's good. So by partnering with software companies like that, we solve problems. Yes?
Do you ever see a time when the GPU and the CPU will be the same? They'll be merged?
Merged. Well, some of the vendors are going that way.
It's called HG or something.
AMD specifically is looking for ways of doing that, probably not in the workstation space, right? Because we're talking about power again.
Mm-hmm.
And if you have a graphic subsystem that's going to be running at 150 or 200 watts, you don't want to incorporate that